Hello and welcome to today's special video, where we'll be taking a look at the development history of the earlier aircraft built by the Blackburn Aircraft Company. Today's topic was voted on by supporters of the channel over on Patreon, so thank you all very much for voting, and hopefully you all find this informative and possibly entertaining as well. So, Blackburn. A lot of people, myself included, can be found guilty of at least once thinking that Blackburn's design team was occasionally occupied by lunatics, and in reality this is an overly harsh assessment. Blackburn is well known for having a checkered history when it comes to aircraft design, but this was mostly a result of designers being brave and thinking outside the box, rather than being objectively bad. Blackburn designed a wide array of aircraft, with a focus on naval and maritime planes, and many of them were indeed successful. But today we're focusing on their earliest examples, and this of course means understanding where the company came from and how its very first plane came about. Robert Blackburn, born on the 26th of March 1885, was the son of George W. Blackburn. He was educated at Leeds University, where he graduated with an honours degree in engineering. Not long after this, he went to work for his father's engineering firm, Green's. But the generational gap between the two men, as well as advances in engineering practices, led to disagreements in the drawing room, and he left the firm to pursue further study in Germany, Belgium, and France. It was the visit to France that set Robert Blackburn on the path to aviation. In 1908, he worked for an engineering firm in Rouen, and he used to ask for the Friday or Saturday to get off work and go to Le Mans. Here, he watched Wilbur Wright flying one of his early biplanes, as well as the early experiments of Latham, Blériot, Farman, and other French pioneers of aviation. As he had spent most of his brief engineering career arguing with his superiors over the drawback of older, outdated practices, the prospect of this new, young-blooded field of work, as well as the exhilaration of flight, inspired Blackburn to design and build a flying machine of his own. He resigned from the engineering firm in Rouen so that he could move to Paris, and in a top-floor room he began drawings for his very first monoplane. Not long after this, his parents paid him a surprise visit, dear Papa somewhat curious as to why his son was still in France and not returning to his engineering work at home, and Blackburn Jr. managed to persuade his parents to accompany him to the first Paris Aero Show, after which they allowed him to remain in Paris until his design drawings were finished. But when Robert Blackburn returned to Leeds later that year, things were less rosy. Permission to build his flying machine at Green's was refused, partly because it would have interfered with production, but mainly because Blackburn Sr. had not spent a small fortune on his son's engineering and technical training for him to waste it all on these new flying machines. Unable to reconcile their differing opinions, Robert left the firm for good, but his father was not completely heartless, and he gave him a small amount of financial backing and assisted his son with setting up a small workshop beneath a clothing factory on Benson Street in Leeds, and he also lent the services of Harry Goodyear, one of Green's apprentices, to assist with the development of Robert's new project. As to be expected from a mind trained towards engineering, Blackburn's first flying machine was no far-fetched flight of fancy, though it was a bit on the blocky side in terms of looks. At first glance, it looked a bit like an oversized cart. Though not the most attractive design in the world, it was highly original, and Blackburn had approached it with a practical mind. The aircraft he designed in Paris was a high-wing monoplane with wire and king post bracing. Observing the flimsy nature of many contemporary designs, Blackburn built his monoplane for strength rather than lightness. The wing was square-cut and had a parallel chord, and it was bolted across a wooden, wire-braced rectangular box structure. The tail consisted of a long Warren girder, which carried a two-part tail assembly. The forward section was fixed, and at the extreme end of this was a cruciform, all-moving, non-lifting surface mounted on a universal joint. Powering Blackburn's monoplane was a Green C4, a 34 horsepower 4-cylinder water-cooled engine. It was mounted on the floor ahead of the cockpit, and was cooled by two radiators that were attached to the sides of the main structure. Using a chain and a 2-to-1 reduction gear, it drove a two-blade, 8-foot, 6-inch propeller, also of Blackburn's own design, that was mounted just below the leading edge of the wing. The whole structure of wings, framing, and machinery was supported by a trio of rubber-sprung wire wheels, 2 at the front and 1 at the rear. Blackburn himself was to be seated behind the engine, the drivetrain, and radiators, in what could be only a position that offered questionable visibility in favour of weight balancing. A chair from his father's garden was pressed into service as a pilot's seat, and it was mounted on a set of runners as a means of adjusting the centre of gravity. Indeed, the whole point of suspending the weighty engine, fuel tanks, and pilots below the wing was to keep a low centre of gravity, as it was thought that this would help with stability, which of course turned out to not be completely the case, but Blackburn didn't know that yet. His design was in some ways a distinct departure from those of other so-called flying machines, and this extended to the controls as well. Not wanting to copy existing designs, Blackburn did away with the controls that would normally be operated by the pilot's feet. Instead, he fitted his own patented design of a triple steering column. This consisted of a steering wheel that could be turned to operate the all-moving tail as a rudder, it could be pushed forward or pulled back to move the tail as an elevator, or it could be moved from side to side to warp the wings. Blackburn had also intended to fit a patented stability device. A pendulum would admit air from an engine-driven compressor into one end or another of a cylinder, depending on which way the machine was banking in flight, and an internal piston driven by this air would then operate the control surfaces to maintain straight and level flight. This design was never installed, as it proved to be impractical, but in essence, Blackburn had anticipated the need for, and partly designed, an autopilot system, which for 1908 was incredibly impressive. With the design work already being complete before his return to England, construction of Blackburn's aircraft proceeded rapidly in his Leeds workshop, and with the assistance of Harry Goodyear, it was ready to begin experimental trials in April of 1909. This was done on a beach between Marske-by-the-Sea and Saltburn, which was on the northern coast of Yorkshire. It appeared that the monoplane at least hopped off the ground several times, but Blackburn was forced to admit that the 35 horsepower engine was too underpowered for prolonged, sustained flight. Eventually, he was able to at least get it off into the air for some short moments, which for 1909 was still an achievement. Experimentation continued until the 24th of May 1910, when Blackburn had tried to turn during one of his mini-flights, which had so far been brief, straight-line affairs. Suspending himself and all the heavy machinery so far below the wing caused the monoplane to sideslip, its wing dug into the beach, and Blackburn was thrown from his seat. Seemingly unhurt, Blackburn took his monoplane back to the workshop. Here it was found to be pretty much a total write-off, and so he decided to abandon rebuilding it, instead putting the lessons learned into the design of his second plane. The second Blackburn aircraft was also known as the Blackburn monoplane, and they are often known as the first and second Blackburn monoplanes respectively. But the first was also sometimes known as the heavy type monoplane to avoid confusion. This new design bore a strong resemblance to the Antoinette monoplane designed by Léon Levavasseur, which makes sense as this was one of the planes Blackburn had seen in flight during his time in France. And for my French viewers, I apologise if I stuffed up that pronunciation. Like the Antoinette, it was a single-seat, fabric-covered wooden monoplane. It had a squared main wing, which was wire-braced to a central king post, and the fuselage had a triangular cross-section which tapered down rearwards of the pilot's seat. Like on Blackburn's first monoplane, his patented triple steering column was once again employed, but the all-moving tail design was abandoned in favour of the long dorsal fin and small rudders of the Antoinette design. This was a good indicator of Blackburn's realisation that borrowing from other designs was not such a bad idea, especially when theirs had been proven to work, whilst yours had not. The engine selected for this monoplane was an untested but advanced design being developed by R.J. Isaacson, an engineer based in Leeds. It was a 40 horsepower, 7-cylinder air-cooled radial engine, and for the time it boasted several novel features, including pushrod-operated overhead valves and a 2-to-1 reduction gear housed within the hub of the propeller. This new engine promised to be an improvement over rotary engines, as it was a stationary unit, meaning it didn't have to deal with the gyroscopic problems that made rotaries such a headache. The development of Isaacson's engine took some time, however, and when the monoplane was taken to the Blackpool flying meeting that took place between July and August of 1910, it could not take part as the engine was still unfinished. In hindsight, this turned out to be fortuitous, as the undercarriage was struggling to support the weight of the monoplane when it was stationary, let alone moving under its own power. In its original form, the undercarriage was a downward extension of the wooden kingpost, which terminated in a socket that carried a tubular steel crossmember. 2 skids and a pair of wheels pivoted about this crossmember, with the impact of landing being absorbed by a powerful spring at the apex of a triangle of struts built under the engine. Upon realizing that this arrangement wasn't going to work, Blackburn modified the undercarriage several times, testing it out on the sands of the Yorkshire coast until he settled on a design he liked. The front struts, with their coiled spring, were removed, being replaced by 4 skeins of bungee rubber which connected to the ends of each skid via cables to the longerons of the fuselage. In early 1911, Blackburn's monoplane attracted the attention of B.C. Hucks, who agreed to join with Blackburn on his endeavours. On Tuesday, the 8th of March 1911, Hucks taxied around on the sands of Filey for 3 miles before making his first takeoff. Though this first flight did end in a crash after Hucks side-slipped in a turn, upon its repair the monoplane was proven to fly well, and it was used as an instructional machine at Filey. Though it had had a slow start, the monoplane's success cemented Robert Blackburn as one of Britain's pioneering aircraft designers, and he was soon working on his next design project, the Mercury. The Blackburn Mercury could be considered the company's most important aircraft from those early years. It did much to increase the reputation of Blackburn in the eyes of both the public and the government, and its success allowed Blackburn to rapidly improve his design work as more aircraft were built. The Blackburn Mercury was a large, 2-seat development of the second monoplane that was powered by a new 50 horsepower version of the Isaacson radial. Whereas the previous monoplane had a 2-wheeled undercarriage, the Mercury had 4 wheels set in pairs. These were mounted on bungee-sprung axles, which sat upon 2 long skids made of ash, and these themselves were attached to the fuselage by a substantial wire-braced 12-strut multiple A-frame, the structure being designed to deal with even the most inept pilot, as Blackburn's aircraft were now being used as instructional machines, and he wanted them to be able to take the impact of a rough landing. To make wire bracing on the fuselage unnecessary, the triangular sections of the fuselage were precision-built for support, and this was something that would become a bit of a signature for early Blackburn designs. The forward section of the fuselage accommodated a pilot and a passenger in tandem positions, and was covered with polished and veneered wood, and the rest of the fuselage, which tapered down to the tail, was clad in fabric. The original wing on the Mercury had a span of 38 feet and 4 inches. It was built up from closely spaced ribs supported on 2 I-section main spars and 2 secondary spars. To reduce the stress associated with wing warping, the main plane was pivoted about the rear spar and wire-braced to a kingpost built into the fuselage in line with the front spar. It also featured wingtip skids to help reduce damage in the event of it side-slipping into the ground, which for a lot of early monoplanes happened, as the stall speed and the flight speed was so close. When completed, the first Mercury was exhibited at the Olympia Aero Show in March of 1911, before going to the newly established Blackburn Flying School at Filey. It was in this aircraft, and other Mercury models, that B.C. Hucks would set a series of aerial firsts, both specifically for British pilots and globally. In fact, the day before Hucks went to earn his official aviator's certificate, he flew the Mercury from Filey to Scarborough and back, averaging 50 miles an hour and climbing to 1,200 feet, at the time making it the highest flight then made in northern England. Usually, the Mercury behaved well, but during the attempt to get his aviator's certificate, the air screw sleeve overheated, seized up and broke, causing the propeller to fly off. Despite the unfortunate problem of losing his propeller, Hucks managed to sideslip his Mercury to the ground, and he was then granted Aviator Certificate number 91, with only a few minor injuries for his trouble. The first Mercury would be flown by Hucks during his brief time as an instructor at Blackburn's flying school, but he was then sent off on a promotional tour with another Mercury. Hubert Oxley, who succeeded him as instructor, had the first Mercury modified so that the front passenger seat was turned around to face aft. This would give the flying student a chance to observe the pilot's control movements. Buoyed by the success of the Mercury, Robert Blackburn got serious about business in aviation and labelled his operation the Blackburn Aircraft Company. During the next couple of years, several Mercury variants were built, including two with steel tube fuselages, the first in Britain to have such a thing. The flying school at Filey prospered, and Yorkshire found itself becoming one of the heartlands of British aviation. Two Mercuries were built as single-seaters and known as the Mercury II. These were both entered into aerial contests over the summer of 1911. Aviation being a very hazardous adventure during these early days, both of these planes were wrecked in the pursuit of greatness. But one of them was not a total write-off, and it was repaired, converted into a twin-seater, and sent with B.C. Hucks on a charity tour of the West Country. Of all of the events in Blackburn's early history, this tour was probably the most significant, as it did much to put Blackburn, and aviation in general, in the forefront of the public mind. At the Taunton Fete in Somerset, Hucks performed two opening flights of the tour in front of a crowd of over 10,000 people. Following this, and due to a railway strike, he flew the last 25 miles of his next leg to Minehead in 22 minutes, managing to outfly the telegram which was to have announced his arrival. The tour was a huge success, featuring numerous sensational events for the time, including the first double crossing of the Bristol Channel by air. During this tour, the Blackburn Mercury displayed a remarkable degree of sturdiness for a time when aircraft were notorious for their fragility. Over the course of 3 months, in which the Mercury logged over 1,000 flying miles across 90 flights, it only needed repair work 3 times. Once for parked damage it received in a gale, another for a forced landing in a cabbage field, and the third was not really due to damage, but rather the fact that the clean white wings of the Mercury were now stained black by the sheer number of signatures that had been written on it over the course of the tour. After this period of touring, this particular Mercury was sent back for an overhaul, and then it was loaned to Lieutenant W. Lawrence, who wanted to use it in an attempt to cross the English Channel. Unfortunately, this attempt was curtailed during an early test flight, when a bad landing put the aircraft on its back with significant damage. While under repair at Leeds, it was modified for use back at Blackburn's flying school. The wingspan was increased to 36 feet, the wing roots were cut away to improve the pilot's downward view, the undercarriage was simplified, and the engine cowling was extended further back to form an upper covering over the instrument panel and to give the pilot some level of protection. In this new form, it became the first Blackburn aircraft to receive an official designation, with each rudder bearing the inscription Blackburn Monoplane Type B. With the possibility of military contracts looming ahead, the Army and Royal Navy were now beginning to take keen interest in these new flying machines. The flying school was relocated to Hendon so that said military could better observe Blackburn aircraft, and it was here that the Monoplane Type B would spend the rest of its days. The success and reliability of the Mercury planes thus far, well proven by the Hux tour, prompted the construction of a third variant, which at the time was called the Mercury Passenger Type, but it is more commonly known as the Mercury III. This was a three-seater, structurally similar to the earlier version, but with main spars of tubular steel filled with wood. Other changes included a foot accelerator, which could override the hand throttle, and aluminium panels covering the engine bay. It appears that several Mercury IIIs were built, but a few specific examples are worth discussing. The first did not last long. Powered by a 60 horsepower air-cooled Renault V8, it was flown by Hubert Oxley, who took it on its maiden flight on the 29th of October 1911. After this, he used the Mercury III for a series of passenger flights near Filey. His favourite trick was to dive steeply over a 300-foot cliff, pull up, and flatten out to land, which was very exciting, but also very, very dangerous. And on the 6th of December 1911, during a particularly steep dive at 150 miles an hour, the wings broke up and the fuselage plummeted into the sands with fatal consequences. The second Mercury III, this time with a 50 horsepower Isaacson engine, had an easier life. It further differed from the previous Mercuries by having the top rudder raised above the fin, removable inspection panels behind the engine, and no wingtip skids. After an abortive attempt at a long-distance flight from Filey to Leeds, it would eventually find itself in Hendon alongside the Model B Mercury, where it was used for flying lessons and as a demonstrator for military inspections. The third Mercury III, built for naval flying pioneer Lieutenant Spencer Gray, had polished aluminium side panels as far back as the cockpit. The evolution of the front fuselage, which began when the tanks on the Mercury IIs were lowered and covered, was finally complete with this machine. This had a curved decking over the tanks, which followed the line of the circular cowling as far back as the cockpit, where its shape was used to deflect some of the slipstream away from the pilot's face. Coincidentally, this modification would also then be used on the Mercury that Hux used in the earlier tour, when it was turned into the Type B. This machine was used by Spencer in several cross-country flights, until it too ended up in Hendon as an instructional airframe. There are several claims that at least 9 Mercury IIIs were built, but at best there only seems to be a record of 6. They featured prominently at Blackburn's flying school in Hendon, and they were often flown there from 1911 until the school's closure in the spring of 1913. Following the Mercury was the Blackburn Type E, which was the company's first military design. By mid-1911, the potential military applications for aircraft were becoming more apparent, especially as Blackburn and other British pioneers were now producing a number of sturdy, easy-to-fly aeroplanes that challenged the early dominance established by the French. In November of that year, the War Office issued its first military aircraft specification. It called for a 2-seat reconnaissance aircraft that could carry a useful load of 350 pounds, along with essential equipment, have a climb rate of 200 feet per minute, a top speed of 55 miles an hour, a flight endurance of 4.5 hours, and an altitude endurance of 1 hour at 4,500 feet. For this, Blackburn took the adventurous step of making metal the prominent material of his design. The main wing was built up from 2 tubular steel spars, and the fuselage was also made up from steel tubing. To make repairs faster and easier, the triangular fuselage had 32 detachable and interchangeable vertical struts, and 58 cross members, all made from steel, joined by riveted clips, and it was all clad in aluminium sheets. The tail unit was also built on a steel tube framework, with the control wires running inside the fuselage, as was the simplified but sturdier undercarriage. This monoplane was built alongside another that also featured a steel tube fuselage, a single-seater built for Lieutenant W. Lawrence for use in India, and when completed they had the distinction of being the first British aircraft to be designed and built with a metal fuselage. Unfortunately, this also contributed to the Type E's complete failure. Although it was powered by an improved 70 horsepower air-cooled Renault V8, it was found to be too heavy to get off the ground, and in fact it would never do so. This was probably a combination of the added weight of the metal, and also that of the extra fuel required for the endurance specification, much of which was carried underneath the fuselage in a cigar-shaped fuel tank. Attempts to improve the aircraft are indicated on company records. However, the project was abandoned at some point in the later half of 1912. The next aircraft was a one-off model built for a private customer, and it represented several improvements in Blackburn's design thinking. It was a single-seat monoplane built for a Mr. Cyril E. Falcon, who had qualified for his aviator's certificate on the 19th of October 1912, and not long afterwards he placed an order with Robert Blackburn for a new monoplane. Known simply as the Blackburn Type D, or the Blackburn single-seat monoplane, it was smaller, more compact, and more streamlined than the Mercury's, but it retained the triangular section fuselage and wire-braced warping wings. Externally, it featured several differences that gave it a more modern appearance. This included curved top decking, an aluminium-plated front fuselage, a one-piece rudder with a divided elevator, and a simplified two-wheel bungee-sprung undercarriage. One notable departure from previous Blackburn models was the controls. For this, Blackburn abandoned his patented triple steering column, choosing instead to have the rudder operated by a footbar. The aircraft was completed with remarkable speed, and it flew for the first time near the end of the year with Harold Blackburn at the controls. Though he worked for Blackburn as an instructor, and shared the same name, he was of no direct relation to Robert Blackburn, which can sometimes be a cause for some confusion for those who don't read much into this sort of thing. He took the aircraft for a series of demonstrator flights around Yorkshire, which included visits to Leeds and Wakefield, and then the aircraft's owner, Cyril Foggen, took it up for the first time on the 24th of March, 1913. Cyril was pleased with its handling, especially the rate of climb, which Harold Blackburn had called a marked improvement over previous models. Following these first flights, a few changes were made. The wingtips were slightly rounded, the original hooked undercarriage skids were changed out for the less lethal hockey stick style ones, and the engine cowling was extended down to the level of the longerons. This was due to the painful tendency for the engine to send exhaust fumes and hot oil back into the cockpit, which didn't really make for safe and enjoyable flying. Over the course of 1913, both pilots flew the plane regularly, and Harold Blackburn showed off its capabilities in a series of demonstration flights. He made a series of cross-country flights without incident, performed a mass leaflet drop from 1,200 feet, and he made one of the earliest attempts at accurate navigation, when he flew to Harrogate with the aid of a map and a compass. Though he liked it, Cyril Foggen owned the Blackburn monoplane for less than a year, selling it to Montague F. Glue, whom he met at Blackburn's flying school at Hendon. Though Glue appears to have flown the monoplane more than Foggen did, he had considerably less luck with it, crashing multiple times over a series of demonstration flights. His last crash in the Blackburn happened on the family farm in Wittering. The extent of the damage, combined with the outbreak of the First World War, prevented any repair work, and the monoplane was stored in pieces in a farm building. Here it lay, gathering dust, and also having a good amount of hay piled over it, until it was finally rediscovered in 1938 and sold to Richard Shuttleworth. Though the work was held up by the Second World War, the monoplane was eventually restored, with a good portion of the original components retained, though it did feature a newer engine, main spars, and cowling. Its first post-restoration flight was made on the 17th of September 1949, and it has remained with the Shuttleworth collection ever since. In line with their founder's original intention, Richard Shuttleworth being passionate about the full restoration of an aircraft to airworthiness, it is still flown to this day when the weather allows it, making it Britain's oldest flying machine. It's also a forgotten movie star, as it featured briefly in the film Those Magnificent Men in Their Flying Machines, and it appears during a scene where it has to be hastily moved out of the path of an out-of-control, tailless biplane with an utterly terrified Captain Rumpelstiltskin at the controls. As a quick aside, this is probably my favourite aviation film, and I plan to do a special video where I cover the aircraft featured in it, so keep an eye out for that in the future. Blackburn's next aircraft was the Type I, which is sometimes referred to as the Type I due to a confusion with Roman numerals. The first Type I was ordered by Dr. M.G. Christie, who had observed the Blackburn single-seat monoplane with interest, having been acquainted with Cyril Foggen at Hendon. The Type I was ordered as a two-seat monoplane, and it was completed in the summer of 1913. It bore a strong resemblance to the single-seat monoplane, and structurally the two were almost identical. There were still some differences. With the Type I, the wingspan was increased to 38 feet, and it was equipped with a more powerful 80 horsepower Gnome Lambda rotary engine. Instrumentation included a large inclinometer mounted on the starboard wing pylon, and like the previous monoplane, the Type I featured a contemporary control layout. The pilot and passenger were sat in tandem, with the passenger in the front. Though that sounds impractical from the perspective of visibility, the passenger was seated over the centre of gravity, so that if the pilot wanted to fly solo, they could do so without the addition of ballast. The Type I was delivered at the Yorkshire Aerodrome on the 14th of August 1913, and Harold Blackburn took it up for its first flights, taking it all the way up to an impressive 7,000 feet in 10 minutes. Following this, he began a flying program where the aircraft visited local towns for flying demonstrations during the week, and then on the weekend he would take the aircraft's owner for longer cross-country flights. These included a flight in August that covered 75 miles in 70 minutes, which for 1913 was still no small achievement. The aircraft's biggest achievement came when it won the 100-mile War of the Roses air race, which was being hosted by the Yorkshire Evening News. Harold Blackburn, taking Christie along for the ride, braved poor visibility to guide the plane past York, Doncaster, Sheffield, Barnsley, and back to Leeds in the 100-mile circuit, beating the Avro 504 prototype flown by F.P. Raynham, who was carrying H.V. Rowe as his passenger. Following the race, the Type I was modified in two stages. 2 holes were cut in the nose cowling to improve engine cooling and the air supply to the carburetor, a hinged inspection panel was installed to facilitate engine priming, and the externally mounted inclinometer was reinstalled inside the cockpit. The second stage of modification occurred in December, when the large double cockpit was split into 2 individual spaces, divided by metal sheeting. Around this time, a second Type I was built. This was a single-seat model with a small cargo compartment replacing the front passenger seat. Instead of the inverted V structure for the king post, this one had a single vertical king post encased in a streamlined fairing. Structurally, it was pretty much the same as the previous Type I, but this version was easily recognised by the uncowled front section of the engine. This, and a return to the old triple steering column, made the plane a bit of a callback to the old Blackburn Mercury. Harold Blackburn flew the aircraft continuously throughout the winter of 1913-1914, and in one exceptional flight from York to Leeds, in appalling weather, the Type I managed to stand up to gale force winds and land in front of a rain-soaked crowd of 10,000 people. The original Type I built for Christie has the distinction of operating the first scheduled air service in Britain, running flights every half hour between Leeds and Bradford. Again, this was done with Harold Blackburn at the controls, and he had plans to form a flying display team with his old racing adversaries at Avro, but the outbreak of the First World War led to the British government commandeering both the improved Type I and the Avro 504 prototype. The success of both planes inspired the construction of a third Type I. This was an updated version of the two-seater, and it featured several differences that set it apart from its predecessors. And because of this, it is often referred to as the improved Type I. In this, the 80 horsepower Gnome engine was almost fully cowled over, the central fuselage was considerably deeper, the tailplane was cut back so that it did not extend forward of the fin, the tail skid now consisted of 2 steel rods, and there were no wedge strengtheners where the front undercarriage struts met the skids. The exact date for its first flight is unknown, but Australian pilot Sydney Pickles flew it multiple times starting from the 9th of July 1914 until it too was commandeered at the outbreak of war. Of little military value, it was converted into a floatplane trainer by the Northern Aircraft Company at Windermere. The original engine was replaced by an uncowled 100 horsepower Anzani, the cockpit openings were widened to facilitate the fitting of dual controls, and a trio of floats were installed in place of the undercarriage. Despite the major engine change and the makeshift undercarriage, it needed no further adjustments to keep it airworthy. Over the course of 1915 and 1916, it was used for the initial training of a large number of Royal Naval Air Service pilots, at one point being flown by J. Lancaster Parker, who would go on to become a famous test pilot for Short Brothers. Its time came to an end when it was finally written off when it capsized on the 1st of April 1916. Moving on to the Blackburn Type L, we encounter a sudden shift in design thinking for British aircraft. 1912 had been a particularly bad year for fatalities, specifically fatalities caused by the structural failure of monoplanes, and as a result, the British government banned them from service within the newly formed Royal Flying Corps. This could definitely be considered a bit of an overreaction, especially as a departmental committee set up to investigate such accidents saw no reason to recommend the prohibition of monoplanes in the RFC. Eventually, this ban was lifted, but the damage had been done, and there would be a long-standing prejudice against monoplanes in British aviation for a considerable time. Though Blackburn's monoplanes had a reputation for sturdiness, and they had suffered none of the recent catastrophes encountered by other manufacturers of monoplanes, he was inclined to stay competitive, and so in 1913 he began work on a biplane design. Not long into this, the Daily Mail announced a £10,000 prize for a Circuit of Britain seaplane race, and Blackburn adjusted his plans to produce an aircraft capable of competing. The resulting design represented a number of firsts for the company. Designated as the Blackburn Type L, it was not only the company's first biplane, but it was also the first dedicated seaplane, the first to use ailerons instead of wing warping, and the first to be designed with a square-section fuselage since Blackburn's very first monoplane. It would also have the distinction of being the first of many subsequent aircraft to be assembled at Olympia, a building that was until recently a disused roller skating rink that Blackburn had purchased in the spring of 1914, and one that would go on to become the famous Olympia Works. It was powered by a 130 horsepower Canton Une 9-cylinder water-cooled radial, and again, hopefully I pronounced the name right, which was built under license, and the 2 radiators that cooled it were mounted vertically on each side of the front seat. An aluminium cowling over its upper section extended rearwards to form a curved decking, and this concealed the 32-gallon main fuel tank which was mounted on the top longerons between the cockpit. The pilot sat in the rear cockpit, where the end of the fuel tank sloped slightly forward to form an instrument panel which consisted of a rev counter, altimeter, compass, and a clock. Controls were conventional and similar to those found on the improved Type I, with a rudder bar and a large aileron wheel mounted on top of a control column. As mentioned, it was the first Blackburn aircraft to have a square cross-section fuselage since the original. This comprised of 4 ash longerons that converged towards the rear, where they were bolted to the rudder post. Like previous models, internal bracing was done with precision-fitted diagonal wooden struts, instead of the wire bracing commonly preferred by other manufacturers at the time. The fabric-covered wings were constructed in a similar way to the previous monoplanes, except now there were two of them. The upper wing, with a span of 44 feet, had a considerable overhang, and so it was supported by sloping struts. Long-span ailerons were installed on the upper wings, and the tail surfaces were similar in outline to previous aircraft, but the rudder area was increased. The Circuit of Britain seaplane race attracted 9 entries, Blackburn included, and the race was scheduled to start at 6 AM on Monday the 10th of August, 1914. Things, of course, were about to change, as on the 6th of August, war was declared against Germany. In fact, many of the entries were actually on their way to the starting point when they were told they were being commandeered by the Admiralty, and the race never happened. The Type L was then taken to Scalby Mills, a section of beach north of Scarborough where Blackburn had built a large wooden hangar, the beach being a popular spot to test their early aircraft. From here it was used for offshore reconnaissance duties, and this would start a relationship with the Royal Navy that would dictate and personify many of Blackburn's subsequent designs. Piloting the Type L was Sidney Pickles, who had flown the improved Type I. Following initial flights, where he encountered problems with engine cooling and control, a series of modifications were made. To solve the cooling problem, the engine cowling was removed, the radiators were moved further aft, and a curved, wide-bladed propeller was installed. The control issues were solved by replacing the long-span ailerons with short-span, wide-chord, inversely tapered units that extended well behind the trailing edge of the upper wing. Following this, the Type L was also fitted with a machine gun, probably a Lewis gun, and then spent some weeks in Scarborough for testing. Not long after this, its service life ended abruptly when its undercarriage clipped the cliffs of Speeton in bad weather, and the airframe was wrecked in the subsequent crash. Following the Type L, we have the Blackburn TB, or Twin Blackburn as it's often called, which was technically their first true military aircraft after the failure of the Type E a couple of years earlier. This has been covered in its own video, but I wanted to mention it as it is here that we see the first of Blackburn's more interesting designs. To quickly summarise, it was a large, twin biplane that had been built to an Admiralty specification calling for a Zeppelin hunter. However, the twin Blackburn was not expected to shoot the Zeppelins, but rather fly over them and drop incendiary darts into them, and then somehow avoid the ensuing fireball that would of course threaten to consume them. This project was pretty much a complete failure. The aircraft was slow, couldn't carry a huge amount of its payload, and if threatened, it was discovered that Zeppelins could simply dump ballast and climb above the Blackburn service ceiling. Oh, and did I forget to mention the fact that this aircraft tried to set itself on fire, repeatedly, every time the engines were first started, courtesy of a pool of petrol that accumulated on the floats due to priming? Well, that's what happened, and the navigator was forced to play a firefighter during every takeoff. Moving swiftly on, we come to an aircraft that started out as an Admiralty design, but then later on became a Blackburn design, and this was the AD Scout. Now, if this looks something like a steel cattle trough that's had an engine slapped on the back and a trio of wings bolted onto it, I can't really blame you. This aircraft was a highly unusual design, and it was another of the Admiralty's attempts at building a Zeppelin hunter. This time they had a requirement for a fighter that could be armed with the Davis 2-pounder, which was a 40mm quick-firing recoilless gun. This gun was to be housed in a small nacelle that also accommodated the pilot. This was directly bolted onto the main spars of the upper wings, and at the back was a 100 horsepower Gnome monosoupape rotary engine in a pusher configuration. Not only did it have the unusual configuration of having the so-called fuselage mounted above, rather than within the gap of the main planes, but it also had its twin fins and rudders spaced apart at a considerable distance of 11 feet. Because of this, the design of the undercarriage was reversed. Normally, you have two wheels spaced quite far apart for stability on takeoff and landing, and a tail skid to keep the plane in line. But with the AD Scout, the role was reversed, with the wheels mounted very close together and a pair of wide-spaced tail skids instead. Remarkably, 4 prototypes of this design were actually built for the Admiralty, but unsurprisingly they proved to be very difficult to handle in the air. On top of this, they were also delivered above their estimated weight, which didn't help performance either, and they were all quickly scrapped. Their designer, Harris Booth, left the Air Department of the Admiralty to join the Blackburn Company in 1916. Here, he attempted to improve upon his unorthodox design, either out of wounded pride or an attempt to impress his new employer. To make the plane nimbler and easier to fly, desirable qualities in general, but even more so if you want to avoid the defensive fire from some angry Germans aboard a Zeppelin, he reduced the wingspan from 33 feet 5 inches to 24 feet to improve the roll rate. The lost wing area was regained by the addition of a third wing, and the so-called Blackburn Triplane was born. Other changes included the widening of the undercarriage to something that looked a bit more normal, the fitting of wingtip skids, as the ground clearance on the bottom wing was not great, and further enlargement of the rudders so that they were even more enormous than before. Only one prototype of the triplane was built, and after some initial engine runs at Leeds, it was sent off to Eastchurch at the end of 1916. It first flew with a 110 horsepower Clerget rotary, and then later this was swapped out for a 100 horsepower Gnome model. Officially accepted into Admiralty control in February, its time was short as it proved to be no better than its predecessor, and it was struck off charge on the 19th of March 1917, to the relief of all. The final aircraft we're looking at today is the elusive Blackburn White Falcon. Its exact purpose remains unknown, but it appears likely that it was used by test pilot W. Roland Ding to liaise with RNAS stations which were receiving Blackburn-built BE-2Cs, and to then bring back the ferry pilots used to deliver them. It was built at the same time as the AD Scouts, and it bore a strong resemblance to the improved Type I monoplane. It used the same 100 horsepower engine that was used later on by the Type I when it was converted to a float plane. It had the same type of main plane, albeit 1 foot greater in span, and it also had the same curved decking over the fuel tank. One noticeable difference, however, was the use of a square section fuselage, which had been a feature on all Blackburn aircraft built after the Type I. As it was built alongside the BE-2Cs that were being built by Blackburn, it inherited some of their parts, notably the undercarriage and tail skid, and this was most likely because these were spare parts that were available at the time of its construction. During the early stages of construction, the flying controls were grouped in the front cockpit, but they were relocated to the rear cockpit before the aircraft first flew. As for a maiden flight, there is no date, but it is likely that it was in the autumn of 1915. Not long into its career, the exhaust collector ring was removed, and at some point the BE-2C undercarriage was replaced by a wire-braced structure without skids. Later in its career, the exhaust collector ring was replaced, possibly by a new unit, and the White Falcon was painted with service roundels. However, it did not receive a military serial number. Sadly, not much else is known about this plane. Photos indicate it attended at least 2 RFC demonstrations, but that's about it. And so concludes our look into the development of early Blackburn aircraft. I've got a few more of these videos planned, and quite a few of them are researched and at least partially scripted, so it shouldn't be too much of a wait until the next one comes out. I've also got a couple of other longer videos partly ready on some other aviation topics, such as the development of early aero engines, the development of aerofoils, the development and use of airships by various nations, and some other things as well that I'm still keeping close to my chest. There's no time frame on when these will be ready, but I am hoping to get them done as soon as possible, so stay tuned for that. As always, thank you all very much for watching, and a big thank you to the patrons, many of whom voted for this video, with a special shout out to Kevin, Deliardo, Bain, FB, Christopher R, Tronathon, Eric Heineman, and John Austin Jr. for their support as Wing Commander tier patrons. Thank you all so much, and I'll catch you all next time. Goodbye.